So, the 14 nanometer FinFET process is pretty much firmly in place right now as customers begin their early design work for the most demanding, high volume, high performance, and power efficient SoC designs. Our topic today is advancing the common ecosystem on 14 LPP, and with me today is Kelvin Lowe, Senior Director, Foundry Marketing, Samsung Foundry, right here. That's good. Dr. Shubhankar Basu, Senior Product Line Manager for Leading Edge Technologies with Globalfoundries, right here. And Wolfgang Helfricht, Product Marketing Director, Physical IP Group with ARM, right here. Welcome, gentlemen, and we'd like to start with Kelvin Lowe, the Senior Director, Foundry Marketing, Samsung Foundry, right here.
Okay, thanks, Sean. So I'm going to just do a short presentation to give you the latest and greatest of where we are at 14. Most importantly, so we are in business for 14 nanometer. I think the 14 nanometer FinFET technology has gone beyond the lab, beyond the fab. We now have products on the shelf, right? Some of you may have it in your pockets actually. A proof point that is the best to demonstrate this is a cross-section taken from a reverse engineering report from Tech Insights, in fact, just a couple of weeks ago. You'll see on the left-hand side a series of FinFET gates. One highlight there is really the tightest contacted gate pitch of 78 nanometer being implemented in an actual design, right? This is one reason why we believe our 14 nanometer has the best logic density capability, right? Meaning you can get smaller die size. On the right, you'll see a picture of 3 silicon fins side by side. Very nice profile there. And mind you, this is just taken randomly from a production silicon of an end product. We are, besides the mobile and consumer products, we are now in advanced stages of engagement with our lead customers, whether it's product tape-out or early productions, in the areas of consumer, computing segment, as well as networking segment. Right? The other thing that we are proud to show today, and Shubhankar will cover a bit more, is the successful execution of the industry's first 14 nanometer single design multi-fab platform. Right now, we actually have 3 out of the 4 fabs that you see on this page in mass production. Okay, this is no mean feat. There's a lot of work that gone behind this, and I'll talk about it in a bit. But before that, just to share with you, some of you may know the Finfet Benefits already of this 3D device. Some may not. So just a very simple chart to show you 28 nanometer planar technology, 28 LPP in this case, and how FinFET can benefit you. Let's start with speed, right? Speed-wise, 14 LPP FinFET can get you up to almost 70% extra performance at the same power. That's tremendous. In fact, that can fuel some of the latest and greatest smart connected devices. Power, ever more important, whether it's a handheld device or even server farms. 14 nanometer FinFET can give you a 60% power reduction. Okay, again, a significant gain. Area reduction, of course, important. We're seeing about a 45% chip area scaling. Okay, so mind you, this is a chip area scaling, not logic gate density scaling. Chip area scaling meaning we took into account logic, memory, analog, and IOs. So 45% reduction. So while we were heavily promoting this to our customers, our R&D engineers in our fabs were busy synchronizing the technology. Really how this expand the supply chain model is where now both Samsung and Globalfoundries, we actually enable a customer to design using a single PDK, right? Meaning one design database, and then later on having the choice and flexibility to source it in our multiple fabs, or maybe one of the fabs, as you see fit based on your business needs, right? Again, the process and the fab folks were very busy making sure that the process technology are kept in sync, because there's not manufacturing a single design in multiple fabs is not trivial, right? Your process recipes have to be matched, equipment tooling has to be close enough, so all of that was completed successfully, right? So today, what are we doing? We are actually now bringing this collaboration to the next level. We have a strong synced process technology, synced design manual and PDK, and now we actually are working with ARM to provide a joint library that consists of standard cells, memories, and IOs. And Wolfgang will talk about the offering in detail. This is exciting because then now you can now start to use collaterals from us to do a single design and then basically decide where to source it later on. So quick presentation there. 14 nanometer in mass production, no longer a lab technology, no longer prototyping, but in mass production. Industry's first single design multi-sourcing option. Collaboration extended to now having a common 14 LPP ARM library. So you can start your designs today with common collaterals and then decide where you want to source it. Hopefully source it in both our fabs and we can all be successful together, right? A little bit of advertisement. Come over to the Samsung booth 933. We have actually a live demo showing how performance and power difference between a 28 versus a 14. You'll see a nice power temperature comparison slide or demo. And of course, we have a leading edge wafers test too, right? Thank you.
Thank you. Thank you, Kelvin. Dr. Basu from Globalfoundries.
All right, thanks, Kelvin, and thanks, Sean, for the introduction. A little more promotion from us. All right, so I'm going to extend the conversation to what Kelvin was presenting on the how we are advancing the common ecosystem beyond the technology sync and process sync between the two companies on 14 nanometer in the 4 fabs. A few highlights on where Globalfoundries truly is. I know that we announced the technology collaboration with Samsung last year in April of 2015. We came back in various various promotional events and we showcased some of our silicon match that we were obtaining with the Samsung Foundry, the source foundry from where we were getting the process technology. Today, since the launch, here is where we have come so far. We have qualified the first generation of the technology in our fab in the beginning of this year. We have the volume ramp for leading products happening as we speak at this point of time in our fab in Malta, New York. And 14 LPP, the next generation of the 14 nanometer technology, is well on course. I'm going to illustrate it with some silicon data. Well on course to meet its qualification deadline the third quarter of this year. Additionally, we have multiple products that are taping out all the way through. Some of them have already taped out in 2014, some taping out in 2015. And 14 LPP volume production is going to start at Fab 8 in beginning of 2016. So a truly remarkable achievement if you look at the progress that we have made between the two companies, syncing up to bring a true fab sync bottom up in terms of process, recipes, tools, learnings, PDK, in terms of the enablement, the PDK, the common PDK and other things. And then, as Kelvin was mentioning, and Wolfgang is going to talk about it more, we have now successfully built with our partner ARM, in this case, a common ecosystem of leveraging the extensively critical ground rule definition for 14 LPP technology. We have the foundation IPs ready now. The design kits are ready for adoption by our customers. So, just to give you, illustrate a little more on the silicon progress that we were just talking about, and this is the data that is coming out from Fab 8, New York, Globalfoundries fab location. As you can see, the first one is 14 LPE and LPP comparison, just to show you. LPP is leveraging fully well the maturity of 14 LPE, which is qualified in our fab at this time. And you can see an accelerated ramp curve for 14 LPP. And on the right side, if you look at it, this is 14 LPP, the standard parameters of showing how the maturity is progressing with respect to a SRAM yield. And you can see that the real silicon data that is coming up is almost in most cases beating the forecasted targets. So we are not only well ahead on course to qualify this technology with reliability and everything taken care of by third quarter, but we are beating the targets in many cases. And also, the last point is on device performance. As you can see, we are receiving or achieving a very good model to hardware correlation in the fab at this time. So why are these parameters very significant? If a customer is coming to, first of all, Samsung has already made these milestones. So if a company or customer wants to build a design using the common PDK in either one of Samsung fab or a Globalfoundry fab, they are today capable of doing that to the common PDK, and they would be guaranteed to meet the model to hardware correlation. That's the most important thing. That's why the validity of the 1.0 PDK holds. And that is the same reason why the ARM IPs that are built using that 1.0 level maturity PDK hold some value, because the customer can really design and tape out products in any of the fabs. A few more bullet points about our Fab 8. We are expanding capacity to our Phase 2 and Phase 3 location in Malta, New York to meet the 14 nanometer demands. And I already spoke about the multiple tape outs that have happened, that are happening right now as we speak. And also the 14 LPP is full qualification in 2015. As you can see down here, that's the go-to target that we are driving for, 14 in 15, which means we're going to fully qualify 14 in 2015 and fully ramp the volume. Okay. Last but not the least, I want to, as a foundry provider, it is important for us to provide a total solution for our customers. To a customer, the time to market is critical. Importance of having a first time right, correct by construction design is extremely important in these leading edge nodes. Otherwise, it is prohibitively expensive. We want to avoid that. The complexity of these technologies do increase, and we have, with our partnership with the EDA companies and the IP providers, and also offering a full turnkey solution, we provide end-to-end solutioning for our customers to achieve that target of correct by construction designs. It is fully aware of all the gamuts that are required, challenges that are required to overcome in the leading edge technologies. The silicon, these are the snapshots or cross section from some of the silicon coming out from Fab 8 in Malta. And as I mentioned, that the IPs are ready, and a full turnkey solution with the packaging solutions are available from Globalfoundries. Okay, so with that, I would like to welcome Wolfgang for your part of the presentation. Thank you. Anyone?
I think it's hot. Do you have to? Okay, thank you very much to Kelvin and Shubhankar for presenting this from a foundry side. I want to give some ARM flavor on this, and more specifically ARM artisans. So we are the physical IP team there. Where do we stand today? Let's got some animation. Okay, so process and IP is available now. I think Samsung deserves some clapping for going from a demo board last year to working phones. Last year, I heard a lot of people saying, "Oh, Finfet, this will not work. It's too early. Wait 5 years." And I think we have in 1 year we have phones available. I don't know who is an S6, but it's really great achievement here. So major performance improvements. So that's Finfet. There's a lot of discussion about this. I think all learned about the major performance improvement, and this enables us to and you to build not only mobile designs. It's also very useful for all kinds of infrastructure, so server networking designs. You have lower leakage. That's everybody is also talking about this. We take advantage of the lower leakage with leakage optimized physical IP. What we mean by this is we have standard cells memories which have very low voltage operations, which have advanced feature sets to reduce the leakage, power gating, for example, but also much more advanced techniques there. And then smaller area, Kevin mentioned this. 1 point on smaller area, it's really important to look to your system. If you only compare transistor, you get only half of the picture, because the big performance improvements allows you to use smaller gates as before. So instead, for example, instead of a high performance bit cell, you can use a high density bit cell. Instead of a 12-track library, you can use a 9-track library. So you get additional area savings by using smaller IP. And then drastically improved low voltage operation. So this little diagram shows the relative voltage. So there is it's relative, so this is nominal voltage. If you reduce your voltage, the blue curve, 28 nanometer, very fast, you are 4 times as slow, so your advantages go away. You cannot use it for memories because the margining would not work, the logic doesn't work. It's a little better in 20, but the big improvement comes with FinFET. You can reduce your voltage by about 30% and at a time where you double the delay. So it's a very large voltage operating range, and that's not so often mentioned in the talks. It's always performance leakage. So take advantage of this. Take advantage of low voltage operation if you design with FinFETs. So going from mobile to enterprise, so we done some improvements, modifications in the IP, and this is for Samsung and Globalfoundries. So it's one IP for both foundries. On the standard cell side, we added architecture which a larger poly pitch. This allows better performance, so you get a performance boost here. We added a high performance architecture to complement the high density library. On the memory side, we expanded the range, make it more useful for more application, but also we added new features, for example, end-of-life guard band. So you can calculate now what would be the impact if you run this 10 years, how would be the behavior change? Nobody cares for behavior of a cell phone for 10 years, but server enterprise, it's really important. So we added some of these features, and then also from a temperature range, we expanded to industry PVT range and AOCV sign-off. So a lot of additions here, and if you look to the products here, standard cell library, 2 types of standard cell libraries with the architecture for high performance, and memory compiler, single 2-port ROM, multiple periphery options, so this allows you to select for high performance or for low power, and then fully programmable GPIO. And the market which we address, high-end mobile, we talked about this, you have this in the news everywhere, but also server and networking now to address this, and implementation solution. There are some additional utilities from ARM to help you with utilizing the ARM Artisan Physical IP. In terms of availability, we have the staged EAC releases. So EAC is production quality releases, so that's an ARM internal term, and they are going on. Now, the platforms are Foundry sponsored. This means you download it from ARM from design start, and then you have a click-through for evaluating, so there's no paperwork at all. If you want to go in production, there's an additional license agreement to sign, but there's no money flow between you and us. That's taken care of by the foundries. And then silicon validation, there was a lot of activity there, and certainly also a running cell phone is a very good validation there. So with this, going back to Sean.
Yeah, thank you, Wolfgang. I have a question. We have some questions for our panelists. Kelvin, are there any customers that are already running concurrent production at both Globalfoundries and Samsung Fabs with a single design database?
So Sean, proud to say, answer is yes. We do have customers, single design, multi-sourcing. So,
Okay.
so that proves the model and the value proposition that we are offering mutually together is working.
All right. And this is for Dr. Basu. Globalfoundries has created a very unique mantra or catchphrase this year. So can you explain Globalfoundries' 14 in 15 slogan?
Absolutely. Indeed, it's not really a catchphrase, but it is intended to be our go-to target. That's how
Okay.
serious we are in Fab 8. The essence is that 14 stands for the 40 nanometer node. The company overall is the Fab is very heavily focused in. First of all, what we are achieving today is we are in the volume ramp stage at this point of time for lead product. We have qualified the 14 LPE version of the technology, so already achieved a couple of milestones. The two other remaining things that we have are supporting multiple product tapeouts that are happening in 2014 on 14 LPP, and fully qualifying the 14 LPP technology in third quarter 2015. Volume ramp for products in 2015 on 14 LPP starting in first quarter 2016. This is a very clear plan. We are not deviating from that. We have excellent silicon progress and data so far to support that plan, Sean. And that's what pretty much defines 14 nanometer in 2015. That's the mantra for us.
Very nice, very nice. Wolfgang, there are always challenges designing for lower process nodes, but what is the biggest challenge for SoC designers on designing with Finfet?
It's a very interesting question. For a normal SoC designer, you will not see the fins. So the fins are hidden, they are taken care of with the IP. So the biggest challenge is really to utilize the immense performance which you get and maintaining a good power budget. So if you simply use everything what you have available, your design will be too hot. So be very careful what you utilize. Certainly you need the latest tools. So all the other vendors here will help you because the latest tools are critical for your success.
Okay. Is a question for any on the panel? If you're designing very high performance and low power devices, what kind of customers can benefit from adopting the 14 LPP technology?
So from a both process offering as well as design enablement, we have now gone beyond just serving the mobile consumer products. The technology has elements, for example, Wolfgang mentioned 84 CPP. That is a bigger contactor gate pitch that's built into the standard cells. Reason for that, although it's still high density, we are actually giving you more performance, right? Standard cells also have a taller track set, not only just focus on high density. So we're trying to push the Finfet offering now to serve and cater for the networking data center and cloud computing. We're seeing a lot of interest, a lot of take-up already happening, spurred by the humongous use of these smart connected devices. So there's a lot of data to handle. The server farms has to be basically have to be capable to handle the bandwidth. At the same time, energy efficiency is important. This is where Finfet comes in, right? Can help us manage energy better, can help us also lower overall cost of ownership for the server guys.
And maybe a follow-up is, when do they look to adopt? I mean, when do they typically?
Well, they are the networking, I would say, customer base adopts this technology extremely early as well.
Okay.
Sometimes as early as the consumer products.
Okay. And now this is for either Globalfoundries or Samsung. This is for Wolfgang. Is the IP that we get from ARM identical for Globalfoundries and Samsung?
Very easy, absolutely yes.
Thank you. Good night. And what a great answer. This is for either Kelvin or Shubhankar. When we talk about a common ecosystem, are all the IPs the same between GlobalFoundries and Samsung?
Okay, so Sean, if I can just take a
Yeah.
little moment extending what Kelvin
Okay.
was mentioning on the previous question.
Okay.
So he already talked about where the early adoption scenario is the marketplace, right?
Okay.
Application specific. He already talked about mobility, lower down to the lower voltage consumption devices, up all the way up to very high gigahertz, 3 gigahertz and upward region, high performance network applications. The beauty is actually in the FinFET architecture itself. The folded gate architecture allows you to achieve that kind of a density footprint if you want, within that. We also have the technology-based push rules for how the scaling impacts naturally. And on top of that, the folded gate architecture and the gate control allows for the lowest leakage points and the electrical performance. To answer your second question, both the companies build their IPs. The fundamental PDK is the same. We, as you know that we don't, as foundries, we would love to have more and more ecosystem partners building IPs on our foundry technology platform, right? And
Right.
using our PDK. So no, we are not restricted to having all IPs exactly synced up. However, since it is built out of the common ground rules, common PDK, they are given a business situation, they are absolutely portable across the different, both the companies and all the fabs.
Very nice. And how are you ensuring processes are matched between both companies?
So this is I think two words, hard work basically.
Yeah.
Hard work. The teams, both sides, during the initial phase of the joint collaboration, we actually had multiple technical workshops. Both engineering teams and R&D teams had cross sites meetings. We went into the detail down to recipe level matching. So process recipe level matching. We shared equipment tooling. This is rather uncommon for two different companies. So we did open up equipment tooling set. End of the day, we ran test chips on both sides, identical test chips, to basically sync up on the end result on silicon electrically, cross sections, product performance, and so forth, right? So and this does not stop. This is not a one-time effort. The sync vehicle has to be run constantly to make sure that the process continues to be synchronized. Yeah?
Excellent. So will this collaboration continue at 10 nanometer?
Well, it depends. I think if the market likes
Okay.
this, we'd like to definitely work together again on 10. So
Very-
it's all about what the customer needs. Yeah?
All right. I can take one question from the audience if you have. Anyone? Okay. May I? Thank you. And just talk right here.
I can see the benefit for a customer to have multiple source for the 14. But what's the benefit or the philosophy for two competing foundries to collaborate on this node?
Well, this is really for the greater good, I think, right? We have been hearing multiple requests from customers that, hey, though we like your technology, we need some flexibility. And it's again back to advancing the supply chain model. We recognize that, yes, we are competing, no doubt, but at the same time, we are trying to serve what the market wants, right? At this point of time, we think there's enough share to go around for both GF, GlobalFoundries, and Samsung to coexist healthily to serve the needs of the FinFET adopters. And the customers also need not be restricted to work with both. They can choose either one if they like to. Yeah.
So I just want to add a few things. We are not the only competitors in the foundry space. There are other competitors that we compete with, right? So the essence is that when we provide a solution to our customers today, it is not about just bringing a foundry up and ready for production. It involves EDA, it needs IP, it needs a total solution offering. Customers, what we have seen from the past experience is that they do not like us or the EDA guys prioritizing between the two of us to build an additional level of prioritization. There are 3 or 4 solutions in the market. Instead, the time criticality of our customers' application need to be respected. we needed to come together to provide one good ecosystem and value proposition, which collaborating with each other, bringing up the fab. Kelvin mentioned that we are open to do business with our individual customers. They also have the, the flexibility of sourcing from both of us. That's the value proposition here.
Very nice. Any other questions? This is great. Thank you so much, gentlemen. Just stay where you are. I want to thank Wolfgang Helfricht from ARM, Dr. Shubhankar Basu from Globalfoundries, and Kelvin Lowe with Samsung. Thank you.